It's 1913. You're driving along in your brand new Ford Model T. The roof is down, the sun is out, life is good. But you're running out of gas. Luckily, the world's first gas station has just opened around the corner, so you pull in and fill up your car in seconds. This was a brand new concept at the time, and it planted a seed that would go on to change the world. The car market exploded, and soon more than 150,000 gas stations had been built across the country, giving people the freedom to travel like never before. Since then, gas stations have evolved from dangerous fire hazards on the side of the street into ultra-efficient pit stops, pumping out more than 3 billion gallons of fuel around the world every single day. We modeled the entire system to show you the hidden engineering behind gas stations, the 100-year quest to master them, and the incredible mechanisms that make them work. But to understand how gas stations work today, we need to go back to a time before they even existed, before gas stations. Most people didn't have cars yet, but kerosene was widely used to power lamps and stoves. To buy it, you would go to a hardware store where an employee would pour kerosene directly into a metal can and sell it to you. When cars started appearing, the process didn't change. The kerosene would go from the store into a can, and the customer would pour it into their car using a funnel. This method was slow, it was messy, and it was dangerous. There needed to be a safer and more efficient way to transfer fuel. That's when American inventor Sylvanus Bowser developed the first practical fuel pump. This was a hand-driven mechanism that forced kerosene from its container through a one-way valve and out of a nozzle on top. One full crank dispensed exactly 1 gallon of fuel. Soon, these pumps began appearing on city streets, allowing cars to be filled conveniently by an attendant. But customers had no way of knowing whether they were actually receiving the full amount they paid for. So, a few years later, the visible fuel pump was invented. The attendant would first pump fuel into a glass tank mounted above the pump, measuring it precisely. Then, by opening a valve, gravity would drain the fuel into the customer's car. Trust had been engineered into the system. The automobile explosion. These small curbside pumps worked well in the early days. In 1900, there were only 8,000 cars in the entire United States, but just 12 years later, that number had skyrocketed to 1.2 million. Cars were suddenly everywhere. Traffic jams built up around every pump, and the small 50-gallon tanks couldn't handle the demand. Worst of all, storing large amounts of fuel above ground meant that things could go catastrophically wrong. And so, in 1913, Gulf Oil opened the first dedicated fueling station in Pittsburgh. Instead of a single pump connected to a small tank, they buried a much larger storage tank underground and connected it to 6 pumps, allowing multiple cars to fill up at once. On its first day, it sold just 30 gallons of kerosene. By the end of the week, it was selling 350 gallons per day at around 27 cents per gallon. Similar stations began opening all over the country. The automobile had become the ultimate symbol of freedom. The shift to gasoline and a new problem. By the 1920s, most cars had switched from kerosene to gasoline because it burned easily and delivered more power. But this introduced a new and far more dangerous problem: vapor. Kerosene has a flash point of about 38 degrees Celsius, meaning it won't emit flammable vapor until it reaches that temperature. Gasoline, however, has a flash point of around -40 degrees Celsius. This means gasoline is constantly releasing flammable vapor into the air, even in cold weather. Inside storage tanks, vapor would build up above the liquid fuel. Every time someone filled up their car, vapor escaped into the air. All it took was a single spark, and disaster could strike instantly. The self-service revolution, turning gas stations from dangerous fire hazards into safe, efficient self-service stops, required serious engineering. For decades, trained attendants handled refueling, but as competition increased, owners wanted to lower prices. In 1947, Frank Altrick opened one of the first self-service gas stations. By eliminating employees, he lowered fuel prices from 23 cents per gallon to 18 cents, drastically undercutting competitors. But letting customers handle gasoline themselves seemed risky. Many states banned self-service stations. The issue was simple. Customers didn't know when their tanks were full. Spills were common. Engineers needed a solution. The automatic shutoff nozzle. The answer came in the form of the automatic shutoff nozzle. Earlier versions used mechanical floats inside the tank. Modern versions are even more ingenious. Deep underground, however, another problem remained. Inside large storage tanks, gasoline vapor would accumulate above the liquid fuel. When the tanks were refilled, this vapor would be pushed out into the atmosphere, creating a serious fire hazard. Meanwhile, steel tanks corroded over time, leaking gasoline into surrounding soil. Modern engineering solutions. Today, underground tanks are typically made from fiberglass and reinforced composite materials. They contain multiple layers of safety systems. Here's how it works. When a tanker truck arrives every few days, it connects to a surface valve. Fuel flows into the underground tank. As the tank reaches roughly 95% capacity, a flapper valve automatically closes, preventing overfilling. To handle vapor, the truck connects to a second valve. As gasoline enters the tank, displaced vapor travels through this second line back into the truck. The truck then returns the vapor to a processing plant, where it's cooled and condensed back into usable fuel. Nothing wasted, nothing released unnecessarily. When a customer fills up, a pump at the bottom of the underground tank sends fuel upward through pipes and filters into the dispenser. From there, it travels into the fuel nozzle, the most fascinating component of the system. The venturi mechanism. Inside the nozzle, fuel passes through a narrow opening. This creates a low-pressure region thanks to the venturi-effect. Small holes connect to a thin sensing tube that leads to a sealed chamber containing a flexible membrane. When the handle is pressed, a valve opens, held in place by small ball bearings. As long as airflow through the sensing hole at the tip of the nozzle, fuel continues dispensing. But when the tank fills up, gasoline covers that hole. Airflow stops. A vacuum forms in the sealed chamber. The membrane lifts, the ball bearings drop, the lever mechanism collapses, the valve snaps shut instantly. No electronics, no software, just physics. The modern era. After the 1970s, cars became more fuel efficient and required fewer fill-ups. The number of gas stations declined. But thanks to over 100 years of engineering, they became incredibly safe and reliable. Thank you very much for watching, and I'll see you in the next video.